Good day everyone and welcome back to the channel. I've marked the correct side of the board up now. Can't remember if I showed that in the video before or not, but I marked this side of the board. Anyway, I'm going to go cut this up, come back. Actually, I'll cut it up and cut that slot in those two holes and then come back, show you, and then I'll go and draw the tracks on it and then come back again and show you, and then mix up some ferric chloride and we'll etch it and start population. I'll be back soon. Alright, well, that's that made up. So that's our board. I know the slot's not neat. I had to drill a series of holes, try and file it out, and also tried to get these in there and cut the couple bits that I wasn't going straight, but it's alright. I'll show you how it goes in here. And that's how it goes. The board actually can't touch any of the metal in there, even though it looks quite close there. It can't. I'm going to make a bracket. I'm going to have a look around here and see if I did lose the bracket that was in there, but I don't remember ever taking one out, but there must have been one in there, so I'm confused. There again, I don't see a band around here. Oh yeah, I do. Maybe I did lose it. Anyway, that is that. So I've got to draw traces now. Also, this is going to take me a while because when I make circuit boards, as you probably noticed looking around the place, most of my boards I just lay from the top, so I don't bother doing it in reverse and drilling all the holes and sticking the components through. I just solder them from the top. But I'm doing this one properly, not just as a learning exercise for myself, but also because of space constraints. There's not a lot of space in the box, so I've got to just make everything work. You know, the capacitor's got to go to the back of the board, the traces have got to be on the back of the board, obviously, for that reason, blah, blah, blah. It's just, yeah, there's a few reasons why, but yeah. Anyway, I'm going to take this off now and start drawing up traces, and then I'll come back and show you and we'll start etching it. I just want to point something out. We do have a little hidden advantage, and yes, if you notice, yes, I did. This was charged and I screwed it on, and cut a long story short, these screws have got these little locking washers on them, and one little bit of metal blew a hole. Nothing to worry about. But anyway, I forgot what I was saying. Oh yeah, so although on this side of the board we're limited in space because of the capacitor, on this side of the board we actually have extra space for tracks. So that can come in handy because we can keep our power traces nice and thick around where we need them, at least. And potentially, maybe, I don't know, but we might, you know, also sneak traces around here that would not, you know, be able to go on the other side. So there is an advantage to me doing this one properly, not just because the capacitor mounts to the back of it, but more room for traces is what I'm getting at. Alright, I'll be back when this is done and we'll etch it up. I'm just getting started preparing this, and I thought I'd just include this in the video, just a trick. If you're trying to work out on the back of the board what area you have for your components, but you know you've got more area for traces because of this capacitor, you can put the capacitor on backwards, and then obviously don't use a pen because it will leave a copper ring, but you can take something sharp like this broken file and just leave a very faint circle in your copper. the thing is, this is not going deep. I'm barely scratching the surface, but I'll be able to see where the capacitor is. So now when I go to lay my traces out, show you what I mean. Now I have this circle here. I know it's a bit hard to see on camera, but trust me, here in person, I can see it really well. And the advantage of this is now I know that all my components have to fit in this area. But I also know I have all of this area to use for traces. I just can't put components here, right? So I just thought I'd just include that again for people who are, learning electronics, want to etch your own boards, build stuff. Just a little pointer for you. It's a handy way of working out how you can fit it without just trying to visualize it or sit there and have to take measurements with a ruler or a compass or whatever. Just put the big object on the back of the board, scratch a circle or square or whatever shape it is around it, and you'll see where you can fit your components and what areas are just for traces. One other small thing that I have to do too, I'll do this on camera too because it might help someone. I have basically two goals with this channel. Three goals: to entertain people who are already into electronics, to educate people who are learning electronics, and obviously to build myself a YouTube channel. So 3 goals. But I want to show this. I'm sorry, I'm just taking the wires out the breadboard. Another good tip I'll share with you, if I can get this out of the way. That's our circuit. That's all of it. Well, minus the compensation components. That's the only one that's a chosen value, that's the final value. Put that off to the side. When you're doing something like this, like if you're working on something that you're trying to modify or whatever, you've got half of it in a box or a chassis or whatever, and the other half you're working on the breadboard or on the bench, do this. Solder bits of tin copper wire to all the wires that aren't small enough to, just because these are tin, fit in the breadboard, and then you can just plug your wires into your board and start working. It's a lot easier than other methods. Let me just say that. One thing we have to do, we have this transistor that mounts to this heatsink. So what I'll do, just move this back off to the side. Got a brand new mica piece there. Yes, this is still the old tube of heatsink compound. I'm sure there's enough in it for this. Let's mount this up first. That's not a screwdriver. Oops. I'm happy with that. Could be a smidgen straighter, but it'll do. I'll just put my Phillips head bit back on. Alright, we need to put this in here. Oops. Like so. And then basically we need to work out how this goes. So hold the board about flat. Get that about center. And then what I'm going to do is I'm just going to draw 3 dots. Alright, they didn't come out perfectly where I want them, but I know what's going on. Move them to there. Now I can go drill those holes, and then I now know where the pads have to go for this device, because this has to also, like this, be mounted in one specific spot. So just another little tip. Alright, that might not be the most beautiful thing in the world either, but you know, just food for thought. Because now when this goes in, you see, we just have to trim the excess pin off the back, but that's where it needs to go. So now I'm going to go make up the traces. I'm not going to do that on camera, but I just wanted to show a couple little tips and tricks that I'm using to get this done with the limited stuff that I've got here. Because it's not like I've got everything in here. I might have a giant component collection, but I don't have every tool in the world. So when I've got to make stuff up, I've got to use my noggin and make it work, you know? So just the right amount of thermal compound. Look at that. It's just coming out that side, just coming out that side, just coming out the bottom. Can't ask for more. Anyway, I'll be back soon. That's going to look very different. Something else I just wanted to go over quickly is how I get from this to this. So what I do is I take a blank piece of paper. Yeah, I was starting to mock up a, what do you call it? Fold back circuit, and then I realised I wasn't going to fit it in there. I take a blank piece of paper and I basically trace around the circuit board, like so. And, you know, right? And then I know where I am. And yeah, I know I keep forgetting things. It's getting late. It is 12:30. Sorry, it's 12:57 now. You can take a component and you can stick its leg through. Oops. Try not to move your board around. You can stick your component leg through to make 3 dots. And then you can just put your 3 dots there where the dots are. That's an easy way of getting a rough idea. You can also take your capacitor and kind of do that. Also will give you a rough idea. Quite close too. I mean, if you look, you know, that's quite workable. So what I do is I draw usually 2 or 3 of them. Sometimes I get it in the first go. Sometimes it just depends. If I really make a big muck up, I'll start a new one. If it's just a little bit, I'll just rub it out with the eraser, you know. But I usually draw 2, sometimes 3, and have a go at different layouts and whatnot. And then once I've got everything on paper, then I basically put this next to it and start copying what I have there. So that's how I do it. Yeah, I'm bloody old school. I don't like CAD software and all that stuff. This is how I do it. So I just wanted to show that for anyone else that doesn't like CAD software and wants to do this. That's how you can do it. So I'm in the process of doing this mock-up on paper that I'm going to then copy onto PCB. But I just wanted to go over a few things. I've gone over a couple of tips already on how I do it. But so the first things I like to do is lay out my current carrying traces and anything that's, how do I say, on where things have got to attach to the board, like wires carrying power coming in, power going out, signals, stuff like that. My current carrying traces, and then I try and think of each end of the circuit. So like, and I also try and think of what the most complicated part of the circuit is. For example, the quad Darlington, triple Darlington, well, it's a quad if you include the output. Anyway, the Darlington stack up, that's just transistors going, you know, emitter to base, emitter to base, emitter to base, the collectors are all paralleled up with a couple of base to emitter resistors. That can be compressed into a small area. So you go, okay, I'll use this little area for that. Over here, I'm doing the voltage doubler. So there'll be a capacitor here, diode here, resistor here. By this point here, we're already ready to put the Zener. All right. And again, we have an easy reference to ground. And then that leaves all this area here to put the comparator circuit. So just a little, you know, I don't know how to explain it. Bit of advice just on laying out. Because if you try and start in the wrong area, you can end up having to try and move everything around and rearrange it 100 times. But if you sit there and think about a few sections of the board and start there, you can leave the biggest amount of space for the most complicated part of the circuitry that way. Just thought I'd point that out. Like I said, this video series is about designing stuff or something. Anyway, I'm going to continue doing this and I'll come back when it's finished and then we'll copy onto this. This is a 1-to-1 scale. This is almost exactly the same thing. All right, I'll be back soon. Just another quick little tip For example, I'm about to run a trace right here, but I know that I want to put a zener between here and here. Now, if I just keep running the trace, I'll get confused and forget that there's a hole there. So go around with a black Sharpie or something after you're 100% certain of the traces that you're going to mark, and put dots where a wire is going to go in, or a terminal, or a lead from a component. And then you see how it starts looking like a circuit board more? Then you can visualize where everything's going. And then when I draw the rest of this trace coming out here off the zener, I see that dot there and there, and I know there's a zener there. I don't just see a trace coming off of that dot, if that makes sense. I hope that makes sense anyway. Alright, so I'm up to the comparator section now. I just wanted to point this out. You see how I basically, the bit of circuitry that could be crammed together, and all the power traces, and then the other power supply for the driver circuitry, I've laid that out first, and that leaves this space here. And when you remember that all these components, the diode, the two caps, the resistor, these two caps for the the common mode network, that's all going to be on the output. I'll even make up a little PCB that goes on the back of the output terminals, or it'll just be soldered across the terminals. I'll probably make up a PCB, but point is, all that needs to go in this space here is quite literally just that 3.3k resistor, and then just these couple components here. In fact, the pot isn't even there because that's on the front panel. So I've got to fit we probably I don't know. Yeah, it depends how many things I end up putting in terms of compensation components, but to tell you the truth, even if I did, usually with these two networks you only need one or the other, but it depends. You see, as the wiper goes down towards this end of the pot, it's going away from this capacitor, which puts more resistance in line with it. Now, if, say, 5k in line with the capacitor is the enough capacitance and resistance for your snubber, for your AC feedback to here, then it'll work. If not, you'll need to add a second network, or you might be able to just completely get rid of this capacitor here if you have a low enough value resistor here and a high enough value capacitor there. That's not going to usually happen because it's going to slow down your response timing. So I usually try and go for meet in the middle, high value cap, high value resistor, low value cap here. Anyway, point is, what, 1, 2, 3, 4, 5, 6, 7, 8, 9. Wait, did I count that? Hold on. 1, we might have that too. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12 very small components. Bear in mind, just here is 5 components. Just there is 5 components. There's 1, 2, 3 transistors, a base to emitter resistor, a base to emitter resistor, and another base to emitter resistor. Oh, and here, a base resistor. So there's actually 6 components just here. We can fit 12 here. So that's how I do my layout. You might have your own way of doing it, but if you want to do it this way, not using software, I recommend picking up these techniques. That's what works for me. If it works for you, good. If you've got a better idea, leave it in the comments section. I'd like to hear it. I may even adopt it. If I sound tired and sick, it's because, well, I still have a cold and it's coming up to 3 o'clock in the morning, so I'm going to bed now and I'll finish this comparator section in the morning when I get up. Alright, I'll be back soon. For you guys, it'll be 1 second. Something else I wanted to point out. Excuse me. Having a cold sucks. Obviously, I'm only saying this for beginners, so please do not be offended. Experienced people. But when you're running traces, anything that's carrying current or grounds traces, like star ground everything as much as you can. Don't say this is our negative in to the capacitor, this is our negative out to the terminal. Don't say put this trace here, coming off of here. Make sure it comes off of the capacitor. Make sure all your grounds are star grounded back to the capacitor, not to here or to here, if that makes sense. Or, you try not to connect them to each other. You see how I've really tried to avoid it as much as possible. Same here, that's what's going on here. Positive comes in here, collector comes out there. Other collector goes out there. Yeah, just be mindful of your layout. Layout is a very, very important thing, and especially as you get up in frequency and yeah, you'll be quite surprised, especially with not just frequency but high impedance circuits. Layout is a very, very important thing. So start picking it up, in your learning phase, in your beginning stage, because it's something that will help you as you move on and design more and more complicated circuits. For example, when we do this, we've got to do controlled impedance traces. We have to worry about certain types of components we use. All sorts of things come into play. With this circuit, not so much, but we still need to worry about noise paths, current paths, stuff like that, So, yeah, enough rambling on, but I just wanted to point that out for the people that are learning, that are new to electronics. Okay, so I've got that done. Now, I've actually left this area here that you can see. I've deliberately left that. That's going to be covered. I'm going to leave that copper there. The reason for it is in the future, if I do decide to add fold back current limiting, it's as simple as adding a transistor or two to it. If I can just get my wits about me. One transistor. Maybe two, depending on how I implement it. But the point is, the transistor would need to have access to this here, the base pin of this transistor that sits here, and it, I could fit it here, and I could just use a Dremel to Dremel the traces out, if that makes sense. So I'm going to leave this section of copper unused, and if in the future I want to put fold back current limiting or something else in it, I've got a little bit of copper that I can Dremel out traces and add a bit of circuitry to. Other than that, that's it. I fit everything on there. The only thing I screwed up on was here. I sort of used texture to go over. I put dots in the wrong spot. So there's not supposed to be a dot there. There's supposed to be a dot there. And there's supposed to be that dot there. But this is just supposed to be a line. So I sort of just went over it all with texture and then again with pencil. To my eye, that's pretty clear. Maybe if I bring it closer, maybe if I put the other light on and bring it closer to the camera. Yeah, now you guys can see too. But that's the entire circuit. So all I now have to do is copy, and like I said, this is 1-to-1 scale, so I literally just have to copy it, and it's that simple. I've got a ruler, Sharpie, board, that's it, copy, and then we'll etch it. And then we'll populate it. And then I'll upload that video, this video. And then the next video will be basically installing the board and doing the compensation components. So on that note, what have I done? I think I've done something wrong already. Oh God. Diode. What have I done? I'm gonna have to pause the video and have a think about this. I've mucked something up, I think. No, I'm a genius. I'm just really good at layout. I didn't spot it. The Zener diode goes between here and here. The 1N4 and 4.8 goes there. And then you've got a spot to put a capacitor across the two diodes. And you've got a spot to put a capacitor here. And a resistor from here to here to go from the output to the base junction. So, yeah. That trace goes to a pad that a wire will be soldered onto the other side of the board, so a resistor can go from there to there, no problem. So yeah, I managed to do it. That's perfect. I won't bother explaining what every trace is on here to you guys because that's just going to be annoying. It'll all make sense when I copy it on there because, like I said, nothing's going to be changed. It's literally just going to get copied onto there. And then when I start populating all the components, it'll start making sense, I guess. All right. That's it for now. I'll be back soon. Something I forgot to mention is when you do a 1-to-1 scale, it's perfect. You can cut this out and put it over this. It's got to be perfectly lined up and then tape it down, secure it, whatever, hold it. But then you can take your drill with your minuscule drill bit to drill the holes for the components, and you can go and drill the holes through the dots on the paper. And then when you take your paper off, you'll have a piece of paper just with holes in it. The drill bit's too small to rip the paper up, don't worry. But you'll have all your holes in your board, and then when you go to copy your traces over, it'll be a lot easier because you'll be sort of connecting the dots, if that makes sense. So there's another tip for you. My apologies. Now it's complete. I forgot the discharge resistor for the main capacitor. I also forgot it on the schematic, so I've added it. I just want to point one more thing out quickly. Try and utilize as much ground plane areas as you can. You saw how these last three traces were snaking, or they are snaking off of each other. Instead of having loops where the noise that's getting fed back through here can end up here, we can make this path twice as thick as this path, and this path 3 times as thick as this path, and it will help share the current back to that star ground point better, if that makes sense. Just trying to give advice for good layout, that's all. So I'm just making the board up. Turns out my paper is just a little bit bigger than the board, and I'm not perfect at drawing either. So this is going to have to do. I'm just going to have to move some of this circuitry that's up the side here along this Darlington pair further down. Instead of this snaking up, it'll just be further down feeding. I just won't have this space left, but it's all right. I probably was never going to put fallback current limiting into it anyway, so who cares? Why is my texter not working? What the hell? Right. Anyways, I'm going to go finish doing this and I'll be back soon. So something I just wanted to point out quickly. You know how before I was saying you can lightly score a line in the copper instead of using a marker, that's fine. But when you go over to mark your traces, you'll have to mark in the direction of the line on top of the line to make sure the ink goes in the line, because if you just go over the top like this in this direction, that sort of thing, it might not all go into the line, and then when you etch it, the solution could end up in that line. I hope that makes sense, but just pay attention to that. Should be alright. It's just something I'm thinking about, and I just wanted to point that out. I'll finish this and I'll be back soon. Alright, so I finished the board layout. I ended up deciding to go for bigger traces and just using up the whole board, because I'm not going to fit fold back current on here anyway, and if I do, I'll just do what I said and mount an extra board in there. I don't think I'll fit that and the shunt in there anyway, but who knows. I can't remember what it was, but there was like one pad or one trace that was missing on here. I think that I had to add. I might be wrong. The reason it's hard for me to remember is because I changed the layout of the comparator area and sort of made everything bigger and thicker. So I can't really remember, but anyway, I'm going to go and just double check this against my schematic, and then we'll start etching the board. I just wanted to show I've been getting the front panel ready. It's just hard to cut this out, because what I basically did was drill a hole, then put a step bit in it, stepped that out to a bigger hole, and now I'm using nibblers. I don't really have something to cut this thicker, tight steel, you know. And yes, these are not straight, because before I bought some nice drill bits, carbide drill bits, I was trying to use this rubbish, and it kept slipping off as the metal was warping in as I was pressing against it, and I just couldn't get it straight. And then obviously, even with the sharpened drill bits, because I've then already got 3 not centered started holes, I couldn't really get it straighten them back up. They were started too far off already, but that's all right. The panel meter is going to go here. I've got to cut, sorry, I'm standing off to the side, you can't really see. I've got to cut down like that. I've already put the pod on there. Banana jacks. Power switch is still there, the LED is still there. Just got to get the panel meter in there. I've checked this and I'm happy with it. I made a small modification. I made this pad here just a little bit longer and this trace a little bit shorter. That was it. So I'm going to go get set up to etch it, and then we'll etch the board. I'm just going to have a little think about if I want to drill the holes first or drill the holes afterwards. The problem with drilling holes afterwards when the traces are small is you can damage the traces, but to be honest, these are pretty thick traces and I'm going to be drilling pretty small holes, so it should be alright. But I'll be back in a minute and I'll let you know what I decide. Alright, I've got the ferric chloride out and it's warmed up. We're just going to plop the board in and watch it etch. I've already warmed this up for 15 seconds in the microwave, so it's just lukewarm, and I've got my board heater underneath this, which I'm just going to cycle the power on and off so it doesn't get hot enough to melt the tray, but it will keep it warm. That will really speed up the etching process. I'll still pause the video and show it in, not a time lapse, well, kind of like a time lapse, yeah, time lapse. What I'm going to do is I'm going to grab this light that's up here. And I'm just going to put it here. Yeah, no, see, that only works for me. I can give you guys a look at how it's going, I guess. I've just got to bring the light real close. That's all right. I'll put the light back for now. Right. I'll just pause the video and I'll come back when it's started to make a little bit more progress that's visible. I just want to point out for people that don't know, I'm sure most people know, this makes, what's the word, noxious, poisonous fumes. So that sound you can hear is my exhaust fan. It's on high speed to suck all the fumes away. Anyway, we haven't gotten very far yet, so I'll pause the video again and I'll come back when we've made some progress. So only in the first stages, but you'll notice the board's turned a pinkish colour, and on the edges the copper's starting to disappear. We can start to see the fiberglass PCB around the edges. So let's put that back in and keep doing this. I'll be back soon. Alright, we should be getting getting somewhere now. Yeah, so you see how now, starting from all the edges, we've got fiberglass showing through. I'll just try and get some of this off. The next time I pull it out, what I'll do is I'll get the light in too. That'll give you a better look. Alright, so I've got the light here this time. Now you can really see how it starts to etch. Just wanted to make sure I didn't scratch any of my Sharpie off then. Alright, let's have another look. It's coming along now, isn't it? Not much copper left, apart from what we want. And as you can see, I decided to drill the holes afterwards. I'll be alright. Just another quick look for you. Not much longer now. You know, in all of that, that's the first drop I've spilt And I've done what, 2 or 3 little etches with this stuff. I don't know why everyone complains about it being so messy. It is messy, I'm just saying it's not hard to not get it everywhere if you're careful. I don't know if you can see it on camera, but all my cat's hairs are floating in the top of this. Jeez. That's a bit better. I swear their cat fur gets everywhere. This will be just about done. Yep. I'll pause the video and come back in a minute. Another minute or 2 and this will be done. Just turn my board heater back on. I've just been cycling the power on it just to keep this about 30-40 degrees. Probably about 30-35. Just not cold, you know. Just makes it a bit quicker. Alright, I'm going to take the board out now. I've left it an extra minute or 2 to what I was planning on leaving it for, just to make sure that any little bits aren't left behind. Actually, let's just do another 30 seconds, maybe a minute. I'll just leave that there and go grab some paper towels to carry this into the sink so I can wash the board off. I'll be back in a sec. Actually, it'll be easier for me to just take the whole tray in there and take the board out, shake it off in the tray and wash it under the tap. So I'm just going to go do that now. I'll just show you the finished product before the ferric chloride gets washed off. And then I'll show you before I take the Sharpie off and then after the Sharpie gets taken off. So that's the board finished. I'm just going to go get this washed up and I'll be back in a moment. So that's the board etched up. Now what I'm going to do, IPA and lots of tissues. Why is my IPA just running out the bottle? Okay, I did not know about that. And yes, it's that easy. PCB way. My way. Okay, I probably shouldn't have done that on my mat, but oh well. for YouTube. And there you go. That is a ready to drill holes and mount components to PCB. Alright, and that is the complete board made up. So I've drilled all the holes through it, ready to mount our components and wires and other things. Oops. So there we go. Geez, my hot plate's still turned on. Oh my god. Okay. Turn that off. Alright. I'm going to go have a look how long this video's been. If it's been too long, I'll upload just this. If it's not been too long, I'll populate the board too. But I've got a funny feeling it's getting quite long. Alright, I just had a look and the video is getting quite long. I think it's at least 45 minutes to an hour already, so I'll just leave it at that and upload this. Makes a good video for making a PCB, then I can put that in the circuit board etching playlist too. So I guess this video will end up in 2 playlists. Alright, I'll see you on the next one.